Okay, so today we're going to talk about non-experimental research, which we were already talking about um, last time with some of the issues surrounding survey sampling. And we're going to, particularly this week, I think the main focus is going to be on some of the designs that go into this. And we'll talk a little bit in a little bit more detail about the ethics of survey research and other aspects of non-experimental research. So we're really focusing on field studies and talking about cross-sectional designs today. Um, so in this example, Daniel Hamermesh has conducted many research studies on the relationship between beauty and income. His findings: better-looking people earn more. Trying to improve attractiveness, be it with closing, cosmetics, or surgical intervention, has just a small impact on earnings. And the quote from the client says, women who go under the knife, as in have cosmetic surgery, make an extra 5 cents per dollar. And so that's in comparison to women who do not have elective cosmetic surgery in terms of what's happening here. So let's look at this. In this sense, in general, like experimental research is not an option, or at least it's not a reasonable or feasible option. And why wouldn't it be? Well, I mean, we can't really make an experimental group have cosmetic surgery. So in this case, we're stuck with the situation that we talked about as a selection effect in the previous, as a feature of our research. As we talked about in previous weeks, as like a threat to internal validity with experimental research. Here, we will have a group of people who have elected to have cosmetic surgery and a group of people who have chosen not to have cosmetic surgery. And so the use of, come on, the use of non-experimental designs. Sometimes this is called correlational research, and people will typically use that, especially in terms of when they're describing surveys, but also any kind of field study. And just the idea here is when we're talking about non-experimental research, all I'm saying is these are cases where we do not have full experimental control. Like it's possible that we could still have what we might refer to as a treatment group and a control group. But people typically, the biggest thing is that people will have typically not been randomly assigned to the treatment versus the control group. People are either due to some force in the environment placed into the treatment group or through their own selection, and as in this case. So people choose to have cosmetic surgery. And as we've said here, we need to be careful with problems with internal validity here. So it's important to realize that what we're going to talk about today is the threats to internal validity are the ones that are particular to non-experimental research. But that doesn't mean that those other things like the subject effect, experimenter effect are not present. And in fact, like essentially under most circumstances with non-experimental research, something like the selection effect is just endemic to this domain. People have selected into our sample in some particular way. And it's not always true. Like economists are fond of what they sometimes call natural experiments, where something that we can condition on that is random in the environment assigns people to different levels of the independent variable or different experimental conditions. That's beyond the pay grade of this class, but it's just something to note. So in that case, there may be no selection effect, or the selection effect may be something that we can control for statistically. But we are not talking about natural experiments. We're talking about non-experimental research. So in here we have the basic idea is like the way that if we think about that McLean's article that I quoted from, it's clearly drawing a causal conclusion that the decision to have cosmetic surgery, yes or no. So we have two groups: treatment group, people who had cosmetic surgery, people who didn't, as a control group. It's the way it's talking about it is, in fact, like you saw that in the women who choose to go under the knife earn 5 cents more per dollar, right, than women who don't. Well, that's using causal language. That's saying that having surgery leads to higher salary. But is that the only thing? Well, it could go the other way, right? I mean, we're talking about electives. We're talking about an elective of non-necessary surgery here. So people pay for this. Maybe like it's possible there could be some insurance coverage for aspects of it. Obviously, not all cosmetic surgery is elective. I want to be clear about that. Like people who suffer from like burns, facial injuries, those sorts of things, maybe having reconstructive surgery, which would not generally be considered elective, would probably be covered by insurance or Medicare or any of those sorts of things. So I just want to be clear that that not all cosmetic surgery is elective. But what we're talking about here is elective. We're talking about things that are like Botox here in particular, is almost always used for purely cosmetic purposes, not reconstructive purposes. So it could be, since it costs money, the association between them could go the other way. And our design is going to have a lot to deal with whether or not we can make the assertion one way or the other. Or there could be a bidirectional effect, which is that people who make more money are able to have elective cosmetic surgery to appear more attractive, and then being more attractive leads to them having a yet higher salary level. So you could have we can have these bidirectional effects where say the dependent variable causes the independent variable, which again has an impact on the original dependent variable. So any of those things can happen, and they can be extreme with what we're talking about this week with cross-sectional non-experimental research. And I should be careful here when I say cross-sectional. What that means is we are measuring the dependent variable and the independent variable at the same time. Now, again, not exactly the same time, right? It could be like, you may have questions about the independent variable first in the survey and questions about the dependent variable later, but under the same conditions, right? And at the same survey administration, let's say. There could be unmeasured third variables as well. So people who have cosmetic surgery, like people who are highly ambitious, may choose to have cosmetic surgery and also have higher salary levels for unrelated, and those may be unrelated to one another, right? So it could be that there is no. That's my that's supposed to be my cross through my no sign. It's terrible. Sorry about that. Here, just erase that. Make it nice and thick. Get my red. Here we go. So there is no actual association between these things. If we blocked out, so we didn't measure this level of ambition, all we'd see is that people who have cosmetic surgery also have higher salaries, but they're not connected in a causal sense. Well, not directly. They're related because they are both a product of the level of ambition. So again, we would see this association. We would see that there's a correlation between them, but it's not a real. It's what sometimes, and we'll talk about this in more detail in a few minutes, but it's what's sometimes called a spurious or spurious, people pronounce it both ways, correlation, in that it's spurious just means that it's not real. It's only apparent. So if we measure these two things, they will be correlated positively. But there may be a third variable, in this case, just as a hypothetical example, we're saying level of ambition, that causes both. So if we measure level of ambition and condition on that, there would be either a very small, statistically non-significant, or actually, like theoretically, actually zero correlation between these two things. And that's called confounding. Right? So we have a confounding variable here that messes up our understanding of the relationship between the two variables that we're interested in, the dependent and independent variable. So those are the two things that are particularly common threats in non-experimental research. So reverse causation is when the dependent variable actually causes the independent variable. Like I said, that can also include bidirectional causation, so that they both influence one another. And that can particularly happen with, I think that's the case with something as simple as like, say, electromagnetic waves, right? It's not like an electric field causes a magnetic field or a magnetic field causes an electric field. They both simultaneously cause one another to exist. So like an electric current moving through a wire induces a magnetic field around it. A magnetic field spinning induces an electrical current inside a wire, right? Those things, that's how things work. Neither one of them causes the other one. They both are just simply interrelated phenomena that arise together for reasons. We don't need to deal with the physics. The spurious relationship is the fact that two things appear to be related, but they're not. So, for instance, like probably one of the most classical examples of this is that there is a remarkably strong positive association with the amount of ice cream consumed in a locale and the homicide rate in that locale. Now, it's not that like, and I mean, if you really spent time with it, you could probably come up with some kind of crazy reason that those are related. Like maybe, you know, sugar. I mean, it is a moderately, I mean, it's a moderately psychoactive substance. It changes people. It changes your metabolism, spikes insulin, does all of these sorts of like parasympathetic things. Maybe it makes people more aggressive. But that's not the case. That's not what's happening. It's that people eat more ice cream when it's hot. People also are more irritable, like their aggression goes up when it's hot. So people are more likely, like there's more violent crime during the summer for a variety of reasons. People are more aggressive, but they're also outside more likely to encounter each other, things like that. So there's lots of reasons why crime goes up, and like crime, particularly violent crime, goes up generally in the hotter months of the year, but so does ice cream consumption. So ice cream consumption and violent crime, particularly homicide, are related to one another. Like if we measure them both, there is a positive association between them. But it's not that ice cream consumption causes murder, and it's not the other way around either. It's not like, when you kill someone, you're just like, oh, I'm so messed up, I got to go eat a big bowl of ice cream to feel better about this. No, I mean, I'm sure that has happened to someone sometime, but it's not a reliable mechanism. What's happening is there's this third variable, this ambient temperature one. So people eat more. The hotter it is, the more ice cream people eat on average. The hotter it is, the higher the rate of violent crime, particularly homicide. So both of these things, reverse causation and spurious relationships, are just endemic to the to non-experimental research. Again, the reason they happen is because we do not have full experimental control, right? When an experiment, we don't worry about spurious relationships because we have a balance, like we randomly assign people to the control versus the treatment groups, and therefore we balance those two groups, right? Such that the only systematic difference between them is the independent variable. Reverse causation, again, because we have experimental control, the only thing that differs between them is the independent variable. And since we've controlled the independent variable under experimental conditions, we have set it. We know that we did that. And we did that randomly because of the random assignment mechanism. So whatever we see in the dependent variable, like any differences we see in the independent variable between our experimental groups and our control groups, has to be, or is logically dependent upon, and logically and therefore causally dependent upon the, okay, here we go. So because we do those things, we know the direction of causation, and we know that there's no third variables that are confoundingly causing the relationship that we observe. Let's just close that out so you can see everything. So with so our basic correlational research designs, we're going to use field studies. So we might be observing or in some other way measuring things that actually happen in the environment, or we might be using surveys, or of course we could be using some combination thereof. In these designs, none of our variables in our framework is manipulated, particularly with surveys. Now we might manipulate something like, so for instance, if you think back to the first week, the Greenberg study with the insurance offices, the status of the office was manipulated. So it was a field experiment. Whereas when we're talking about a field study, we're simply observing things. people can get a little messy in talking about that, but just keep that in mind. So with surveys in particular, which is where we're really going to focus on this, we simply measure each variable and look for correlations amongst the variables. And so we need to make sure that the measures are good. So like we talked about last time, we need to make sure that they are reliable, so that, if we measure somebody today, they would have approximately the same score up to random variation the next day. The validity of the measured variables, we need to make sure, in essence, that the measure that we're giving, like we say we're measuring somebody's job performance, it should actually measure their job performance and not how much their boss likes them, for instance. And the survey questionnaire design, so that there's nothing. I've seen lots of these sorts of things, like one survey that I worked on that was electronically administered once upon a time. There were better correlations between items on different scales that happen to be on the same quote unquote page. It was just an electronic page turner sort of thing. Higher correlations amongst items on different scales that were presented on the same page than there were between items of the same scale that were on different pages. So we have to be careful about how we design things. And that kind of goes maybe slightly above the level of this course, but just something to keep in mind. And in general, we have to pay attention to what are those threats to internal validity. We have to be aware of how reverse causation and spurious relationships could affect and limit our conclusions. So, actually, we talked about this stuff last week, so I'm not going to worry about that. We talked about that last week too. So we've already talked about sampling this term, and we talked about this. So here we're going to talk about the refreshing work study. So of course, in this correlational study, we cannot be sure of the causal direction of the explanation. We've assumed that work-related energy management strategies can cause an improvement in energy levels. Our research design cannot rule out the possibility of reverse causation, that people whose energy is high are likely to choose to do new work-related activities when they are becoming fatigued. So that's the thing here, again, because we've measured these things at the same time. We can't know which way this goes. We can't know whether people are doing new things to make themselves have more energy, or if people who have more energy choose to do new work tasks. We just don't know under these circumstances. And the researchers suggest a longitudinal design would improve internal validity. And we'll talk about those in detail next week. It says week 8, but it'll be week 9, just because we're moving things around a little bit. So here we go. And that's just to say, like, if we had separated, by longitudinal, we just mean if we'd separated these measurements in time. So if we were able to see that when people get fatigued, they do new things, we would know that energy level is causing the behavioral strategy to happen, as opposed to, like, if we saw that people do new things and then they become energized, then we would know. Causality went that way. Since we didn't separate these in time, we don't know. Adolescent school success. It's still mothers who do most of the reading to kids at night and who prod them to do their homework, but adolescent school success in school might depend on how well they get along with their fathers, a University of Charlotte study says. The research published in the March issue of the Journal of Family Psychology found that mothers still do a disproportionate share of childcare, but surprisingly, it also found that children who gain the acceptance of their fathers make better grades than those not close to their dad, said author Rex Forehand. Forehand and fellow researcher Sarah Nuzianen studied 70 adolescents, their parents, and teachers. All of the kids lived in two-parent families and were aged 11 to 17. You can see here that disclosing that, so they've disclosed the sample size, and they've also said that, like, the kids were comparable on these things, that this was the age range, and that they all had lived in two-parent homes. There were no kids with single parents who wouldn't be comparable in this case, because we would be comparing kids who only have a father or only have a mother to ones who have both. And with this research question, we're looking at mother's time investment, but father's approval or acceptance. So that's important. The strong link between paternal acceptance and how well adolescents functioned in school demonstrates that fathers play a bigger role than previously thought. And note that this is published in 1994, so I think that fathers continue to play a bigger role, but mothers continue to play a bigger role on average than fathers do. Just noting that. Acceptance means giving quality time, not being too critical, being supportive rather than laying down dictums. He said, it's letting them see that you're putting in the effort. That's the key in these findings. So again, we're seeing that the claim is a causal directional one. It's saying that paternal acceptance leads to better performance in school. Like that's the way it's being talked about. But again, this was a cross-sectional study. So can we conclude that? The answer is not really. Because, for instance, is it possible that students who are doing better in school, maybe the dads are proud of them, they want to see their kids perform well, and so and I'll say this, like even as someone who's pretty invested in their kids, yeah, when they're doing well, it's a lot easier to be real nice to them than when they're having a real hard time with things. So it's just something to keep in mind, that there are these possible alternative, this could be reverse causation, and it's hard to rule out. So we have paternal acceptance, like the way it's talked about. As I said, paternal acceptance leads to grades, better grades, right? But is that the only possibility? Could it go the other way around, as I just suggested? Absolutely. Without a longitudinal design, we do not know this. We can make arguments for why it might make sense that it's paternal acceptance leading to grades, but we can't prove it without a longitudinal study or an actual experiment to decide which would be relatively infeasible here, right? We certainly cannot easily or probably ethically manipulate the level of paternal acceptance. So reverse causation is a threat. Here we go. Here's one I really want to talk about. So educated nurses. Hospitals' death rates are higher when nurses' education levels are lower, a study of surgical patients found. Nursing degrees are offered by 2 to 3 year diploma programs and 4-year Bachelor's of Science programs. Better educated nurses tend to be more proficient in critical thinking, said researcher Linda Aiken, a nursing professor. In university programs, nurses have the opportunity to interact with physicians in medical schools and develop skills that are important in critical circumstances, she said. The percentage of Bachelor's of Science nurses ranged from 0 to 77% at the hospital studied. The patients studied underwent common operations such as knee replacements, appendectomies, and gallbladder removal. Hospitals where few nurses had Bachelor's of Science degrees had death rates twice as high as hospitals where the majority of nurses had Bachelor's of Science degrees. Some 4 million procedures like the one studied are performed in U.S. hospitals every year, yielding a substantial number of preventable deaths, Aiken said. The current study found that nurse education is critically important even when other factors like surgeon expertise, severity of patients' conditions, and availability of technology were taken into account. Again, that's from a 2003 Gazette article. And here, this is the thing, like this last paragraph here is probably the most critical in this, because let's think about this, is like maybe the higher education usually, especially in the US, is related to better pay. So maybe like better hospitals that can have more money to pay for higher quality nurses, have these more educated nurses, but they might also have better surgeons. So controlling for surgeon expertise rules that out as an explanation. The severity of patients' conditions. Well, this goes back to what I was talking about like weeks ago when we introduced the idea of selection effect. Like I specifically talked about hospitals like using things like sick kids in Toronto or the Mayo Clinic in the United States as an example, that even if people going there have worse outcomes, it's often because these are places of not last resort, but places that are there to treat particularly difficult cases. So like if the nurses with lower education levels were on average dealing with patients with more severe conditions, we would expect more deaths even if their education had no effect on it. So controlling for that allows us to rule that out as an alternative explanation. And here, availability of technology. This is another thing that's sort of a proxy for the quality or the financial resources of the hospital, right? So if they have more technology available, better technology, those sorts of things, it's another indication that the hospital is better. So let's say if, again, the more poorly educated nurses are clustered in hospitals with fewer technological resources, less money, all of those sorts of things, we would probably tend to expect higher injuries and death rates than we would in better supplied hospitals, even if, again, nurses' education has no impact. So looking at this, we can see reverse causation and spurious relationships as threats to internal validity. Again, nurses' education level leading to patient death rate. Is it possible that that goes the other way? That's a little bit harder to see because the nurses' education, in general, the nurses' education is going to precede the death of any patient that nurse is treating. But it is possible that there could be reverse causation in a complicated way, right? So that if a lot of patients are dying at a hospital for whatever reason, that hospital's reputation declines, and as a result, they have fewer patients and therefore less financial resources in order to pay nurses, and therefore they can only hire more poorly educated nurses. That's a possibility. So that could still happen, but it would be more complicated. At the individual level, there's probably no reverse causation here, but at the level that we're talking about, like the average level of nurses' education in a hospital and the death rate of patients in that hospital, it could still be there could still be reverse causation. And there could be something else going on, like location here. If all of our educated nurses are clustered in urban hospitals that have, more educated doctors, more skilled surgeons, more resources, all of those sorts of things, and our less educated nurses are in rural hospitals, we could have a spurious relationship where the apparently causal relationship between nurses' education level and patient death rate is actually driven just by the physical location of the hospital. Um, when we talk about evaluating measures, what is a good measure? And we started dealing with the practicalities of this last week and even to a lesser extent the week before. But we haven't really discussed it. So how are our surveys developed so as to ensure good measurement of variables? Well, the first thing you need to know about is internal consistency reliability. And in essence, this is classical test theory. So I'm just going to write down here the fundamental equation of classical test theory, which is just about see it here, where X is a person's score on a particular item, tau is their quote unquote true score, and E is an error term. So the basic idea here is a person's score on any item in a measure, whether this is, say, like a knowledge test, a cognitive ability test, personality, or any survey measure. The idea here is they have an actual score on it. Well, what we call a true score, which is kind of a bad name because it's just like what they would be like. The introduction to this is actually the idea that if you had somebody answer that question and then you could literally give them a brainwashing so they didn't remember anything about answering it, and then you had them answer it again and did the brainwashing again, answer it again, over like an infinite number of times, what would be the average score that they got on it? And that's what the true score is. So it's a totally hypothetical, fictitious thing. So when we call it true score, it's just what the expected value is on this. And since that's the case, when we do this, we can apply the expectation operator to the whole thing. And so E is the sum of a constant and a random variable. And it's a random variable with, as you can see, a mean of 0. So when we take the average across this whole thing, we get the expectation of x of I equals tau plus 0. So it's just how. So like the expected score on any item, so the average score that a person would get across administrations is just the true score. And so this is where reliability comes into play. The idea here is that a reliable measure does not have a lot of this random error. So that epsilon component, the error component, is comparatively small. So so it has a small variance component. And the way we actually wind up estimating this is, as you saw last week when we were working on how to actually physically or operationally do this in JASP, is we ask a bunch of different questions. Like on a scale, we'll ask several different questions, at least three, about a particular topic, whether it was, say, financial anxiety or financial comfort, as it's called on the actual survey, or conscientiousness, knowledge of Mana 420, whatever it is. We ask multiple questions and we see how well they sort of hang together as we did last week. And so the basic idea here is, as I said last week, in general we want a Cronbach's alpha of 0.7 or above in regular survey research. As I said, people have sometimes made the argument that, like, if it's a new measure, 0.6 is okay, or if it's some way really important for some reason, they might tolerate somewhat lower, but generally not less than 0.6. And if we were using a measure as part of, say, like a personnel decision, we'd want substantially greater reliability, like the minimum for like the typical minimum for like making a personnel selection decision using a psychological or a survey type measure like this would be 0.9. So again, just the higher the reliability, you can think about this as sort of like the more consistent responses are with one another. So 0.7 says that, yeah, basically this is considerably more consistent than it is inconsistent. And you can just basically say, like, the higher the reliability, the less random error is infecting that scale. And we also wanted to say, like we talked, that this is valid, which is that the variable that you are measuring is the variable that you intended to measure. And there's lots of different ways of talking about validity. In this course, we're going to focus on content validity of a multi-item measure. And what we're seeing here is that, like, the dimensions that you would logically expect to see, like, is the thing that you're measuring, does it look like what we would expect, and particularly what experts would expect? So here we go. The way we establish this in this class, we'll go through this example from refreshing work. The major dependent variable was the individual's reported energy level at work. Our measure drew on the well-established vitality scale developed by Ryan and Frederick in 1997. It comprised 7 items rated on a 5-point Likert scale. 1 equals strongly disagree to 5 equals strong. Oh, sorry, it should be the 5 should be strongly agree. You know what? I notice this every year and I have still failed to edit it every single time I go through it. Sorry about that. Anyways, that plus the sample items where I look forward to each new day, I nearly always feel alert and awake, and I don't feel very energetic, which was a reverse scored or reverse coded item. So you can see here, what we're doing here is showing, the authors are showing that this is something, a scale that exists, or an index variable that exists in the literature. They're giving it citations so that people can, if they're unfamiliar with this scale, they can look it up. They're explaining how it's measured, so a 5-point Likert type scale, setting the boundaries, and then giving sample items. And this is the way, like, you should talk about any, like, when you go to do assignments, depending on how you talk about it, assignments 2 and 3, and definitely on the individual project, this is the way you should be talking about scales. And then down here we have, in this sample, the internal consistency reliability of the measure of vitality was good. Cronbach's alpha equals 0.86. 0.86 is greater than 0.7. There you go. We also found that the alpha of the work-related strategies fell slightly below the traditional cutoff for consistency, while the recreational strategies were more consistently rated. So 0.66 versus 0.73. So again, in this case, you can see, like I was saying, they're not saying anything particularly negative. They're just saying, like, oh, this is somewhat slightly below the traditional cutoff, 0.66. Again, if we round to 1 decimal place, it's 0.7, probably okay. The recreational strategies were above the standard threshold. How a survey questionnaire is developed. We could send like a cover letter or introduction, which the usual sort of ethics, we're going to assure that anonymity or confidentiality is ensured, give people an estimate of the time required. So again, if you say, like, and this is usually when you give an overestimate there, which I may have mentioned earlier in the class, but like if you tell someone a study is going to take 15 minutes and it takes them 25, they're going to get mad at you. Whereas if you tell them it's going to take 20 and it takes 12, they don't care typically. So you usually want to be closer than that. So you want, if you think it's going to take people usually about 12 minutes to do it, telling them 15 is probably good. The tone is enthusiastic and polite, and we avoid the subject effect. So we don't want to put them into any kind of particular headspace. So basically, we want, like where it says enthusiastic and polite, also neutral. We're not giving away too much information. We're not telling them too much information about our hypotheses, just what the study's in very broad terms, what the study is about and what they're going to experience during the study. The inclusion of variables. We're going to draw our variables from our theoretical framework. We will probably look for potentially important moderating variables, which helps to establish external validity, right? So that we can kind of like set the boundary conditions, like where we would expect like a strong effect and a weak versus a weak effect. And we would also include additional variables that help to rule out threats to internal validity, particularly if there are any obvious confounds. So like when we're talking about, say, like, well, in particular, the nurses education study, that one did measure 3 potential confounding variables in terms of the surgeon's expertise, the severity of the patient's conditions, and the access to technology or the availability of technology. So again, the thing here is whenever we're trying to statistically rule out confounders, like these third variables that might completely or at least mostly explain the relationship between our independent and our dependent variable, there's always, I mean, there's an infinite number of potential confounds, right? So we can only measure so many. What we want to do is try to measure what seem to be the most important potential confounders, like the ones that seem to us, and this can be why when you're developing a survey study, it's good to get feedback from other people, other researchers, other sources, subject matter experts, so they can help you to identify additional confounds. You're only going to be able to measure so many, but you want to try to rule out like the biggest potential threats. We have to be aware of our order of questions. Typically, we're going to go from simple to complex questions and from general to specific. We want to usually delay sensitive items, like if you're going to ask people about like personal or sensitive matters, you usually want to keep that until relatively late in the survey, so that, I mean, partially like if people see like an overly personal question too early, that may turn them off, whereas if they see it late, they're more comfortable answering questions by that point. We want to always avoid the subject effect, and we want to try to do our best to avoid the experimenter effect. So we don't want to influence people, and we don't want to provoke reaction. And that we just want to try to get their honest opinions about the questions that we're asking. Partially, we do this through ensuring anonymity or confidentiality at the very least. We want to use phrasing that helps in questions. So like cues stayed the memory and like to sort of set the time frame. So like a lot of times if you're asking survey questions about what emotions people are experience, we're going to set a time frame in them. So like in the last 2 weeks, have you experienced this list, like which on this list of emotions have you experienced? We also might like want to like give people instructions to think about a particular time, like think about a particular time. Well, like in the example of, sorry. So for instance, like one thing is that's used sometimes, it's more of an interview or qualitative technique, but the critical incidence method of job analysis, where we present to people this STEM to think about a time when they had particularly good performance, and then later think about a time when they had particularly bad performance. And so now they're thinking about that before they start telling us about that situation, like giving us explanations. We want to be careful about phrasing questions about sensitive issues. We want our questions to be well sensitive. attendant to the possibility that people could be troubled or offended by this. And we generally also want to avoid double-barreled questions. So we want to typically avoid questions that are like have two different parts that are held together by an and or an or. Because asking those sorts of questions can make it difficult to know, to interpret what people are responding to. So like in general, if you have a double-barreled question, you think it's important, it's usually best to break that apart into two questions. And they may each be slightly different than you would have phrased them if they were together. But if you want to get the information, you usually want to separate it so you know specifically whether people are responding to this part or the part after the conjunction. With ethical issues, with collecting survey data, most of the ethics are pretty similar to experimentation. We want to, in collecting survey data, we want to be aware, am I coercing people to participate? Are you putting any pressure on them? Don't want to do that. With experimentation, in general, we were asking, will being in a control group harm participants? Or even more so, like, is there a possibility of harm greater than everyday life in being in the experimental condition? Design of research measures. Have I addressed the major threats to internal validity? Are you measuring confounders? Have you taken care to do these sorts of things? And when reporting results, am I violating standard research practices? Like, did you collect the data in an ethical manner? Did you honestly and correctly analyze the data in the sense that your data analysis actually addresses the real hypotheses? Are you taking the effort to disseminate the findings? Like if you collect data on people for research purposes and you never try to present them at a conference or publish them, you've essentially wasted those people's time. I'm not saying that you're absolutely always going to be able to publish or even present at a conference, but failing to try to do so is a waste of your participants' time. And the final thing to deal with this is people who have sports cars have high incomes too, but that doesn't mean you should go out to buy a sports car if you want to get rich, right? And the basic idea is everybody knows that, right? Like in general, like buying a fancy car isn't going to make you rich. If anything, it's probably going to make you poor because like a really fancy sports car, not only are they expensive, but they tend to have relatively high maintenance costs. They use a lot of gas. They're expensive to own. Like they have a high cost of ownership. So if anything, buying something like that is actually probably going to make you poorer. And most people know that. Like it doesn't surprise people. Like very, very few otherwise rational people would say, if I buy this car, I'll suddenly get rich. Now it might be, it could be part of a strategy. Like you could, if you're trying to brand yourself in a particular way such that that's what you're selling, like as a lifestyle coach or something, it could make sense to buy a car that is quote unquote better or more impressive than what you can realistically can afford as an investment. But that would be part of a particular strategy for essentially branding yourself and marketing yourself to potential clients. I wouldn't go around recommending that, but it could make sense. But no one is ever going to think that just having the car is going to make you rich because there's an association between having a lot of money and having a fancy car, right? That's not the way it works. It's that you have the money, therefore you get the fancy car, not the other way around. And that doesn't surprise anyone, and it should not surprise anyone. But when we start talking about things that are more abstract, this reverse causation issue does get people all the time. People tend to think about what makes sense to them as the independent variable causing the dependent variable, even though they don't have any direct evidence of that. And that can trip you up because people are wrong about that. Anyways, that's all for the recorded lecture. Have a good one. See you next week.